So this is June 2023 exam from the province of Gauteng. So we are going to take a closer look into this departmental, which is a provisional examination that is from the province of Gauteng, given June 2023 for grade 9 mathematics. That was 1.5 hours, max 75. Okay, so that was it, guys. As you can see, it was a clear part in your instructions and information. Make sure that you read everything, especially if necessary, round off your answers to 2 decimal places, unless otherwise stated, unless you're given a statement on that, and make sure that you clearly show you're working. Everything must be clearly shown when you are presenting your work. Be very, very sure about that. Okay, question number 1, we are given answer question 1.1, that is the first part of the instruction. Follow the instruction that you are given. So you are told that here, answer 1.1 to 1.5 by choosing the correct answer. Just choosing the correct answer. Circle the letter next to the correct answer. You're supposed to circle it. All right, 1.1 we're given, which equation illustrates the multiplicative inverse property? The multiplicative inverse property. What is it about the multiplicative inverse property? It states that a number, when it is being multiplied to its inverse, which is the multiplicative inverse, it must give us a 1. A number, when multiplied to its multiplicative inverse, this is the multiplicative inverse, you must get a 1. So given a number such as a 2, the inverse of a number is 1 over that number. So it's 1 over a 2 like this. We must get a 1. That is the identity. So meaning to say, if you are given a letter, we just need something of this nature. So this is not what we have. This is 1 times y equal to y. This is not multiplicative. So meaning to say, this is totally out. Okay, sorry for that. I need this to come back here. All right. So this is totally out. B, y times 1 over y is equal to 1. 2 times 1 over 2 is what? This is exactly what we have. So this is just like there's a 2 here. All right. As long these two are the same, 1 over y, which is the inverse. So this is the number, this is the inverse, getting a 1. So this is actually correct. 1 minus 0, this is not multiplicative. This is not, okay. So that is B was going to be the correct answer there. 1.2, given this equation, for which value of x will this equation be true? For which value of x will this equation be true? They are simply asking you, solve for x. That is the question. They are simply asking you to solve for x in another way. Solve for x. How are you going to solve for x if we're given just an equation and you're asked to solve for x? Given this equation, 4 into x plus 1 is equal to 3x plus 10. Expand the brackets. All right, sorry for that. So you are going to expand the brackets. With the 4 that is outside of the bracket, there is a number that we are seeing that is affecting our bracket. With that number, that is, you multiply everything inside of the bracket. So distribute this by 4. That is 4 times x. That is going to give us 4x. 4 times this 1, that is a 4. So this is equal to 3x plus a 10. So as we know that if you're solving these equations, what we need is to collect the terms with x to one side of the equation. So 3x will to the other side of the equation, jumps the equal sign, it changes the sign. So there we've got already 4x. The 3x, it carries the negative on the other side of the equal sign. So the 4 taken to the other side is going to be a minus. So that's 10 minus a 4. It was a plus. It changes the sign once it crosses the equal sign. So that's 4 minus 3, which is 1x. 1x is same as x, guys, all right? Then 10 minus 4, that's a 6. So meaning to say, if I divide by 1, I'm going to have the value of x, which is what? Which is a 6. So there, the value that was going to be best was going to be a 6. So if maybe you are stuck, you do not know this in exam, how can you answer this question? You can do this as a trial and error on your calculator. Let's say, because this is just a you choose the answer, so you can just do this. When x is -6, we're going to start with -6, all right? That's 4 into x plus 1, and our x is -6. So it's going to be -6 plus a 1 like this. Okay, so if you simplify this, you're going to obtain -20. So on the left-hand side, if our x is -6, when x is at this a here, we are obtaining -20. We do the same thing on the right-hand side. Just do this on the right-hand side. 3 into your x, which is what? -6. So you can just do this to try, because this is this you've got A and B, C, so you can choose -8. So as you can see, this side we are getting -8. These two sides are not the same. -20 is not equal to -8, so it means -6 is out. Okay, this is how you can do it. You do the same thing if this is a 6, because maybe, like I'm saying, maybe you've got a problem in solving your equation, but you're supposed to know equations. When x is 6, you're going to add 6 plus 1. That is going to be like this, 6, that is 28. So we're obtaining 28. We do the same thing on the right-hand side. That is going to be 3 times 6. Remember, our x there is the 6. So that's 3 times 6 plus a 10. Then we're going to add a 10. This is 28. So as you can see, the left-hand side and the right-hand side are equal when this is a 6. So meaning to say our answer is correctly a 6. So we can do that. You see that this is going to be wrong. This is going to be wrong also. So that's paper 1 for you. You can do that. So the answer there was going to be at B. 1.3, in the sequence that you're given, the ratio is, what is the common ratio? How do you find the common ratio? So this is easy, guys. Whenever you're given your terms like this, just take them as the first term. This is 4, this is 2/3, this is 1/9, this is 1/54, and so on and so on. So I want you to take this way. Whenever you're given your terms this way, this is how you take it. You say this is your first term, so you're going to write T1. This is your second term, T2, third term, T3, and so on and so on. So the common ratio, okay, I'm going to represent that in terms of R to represent what? The common ratio. Let's say R represent the common ratio. This is it. You're going to take this as the second term over the first term. So you take this over this. Also, third term over the second term. So it's also equal to the third term over the second term. Also, the fourth term, as long as you take it this way, to the third term. So it can also be the fourth term to the third term. Guys, I hope this one you can take it, and you can take it by heart. This one you can know it. I understand this. You can know this. So you can use any part. So in this case, I'm just going to use what? I'm just going to use T2 and T1. Just going to use these two terms. So using this, it means our R is going to be T2 over T1. That is our T2, the second term. That's 2/3 divided to the first term, T1, represent the first term. So this is you and your cup. This is 1 mark. So there I don't see anything important for you guys. I just need you to use a calculator there. Put a fraction there. All right. So you're going to put a fraction. This is 2/3 on that fraction. You're going to have 2/2/3. All right. So that is 2/3. All right, my calculator. Let me just save a bracket first like this. You just want to put as it is on this part. So this is 2/3. Then I'm going to close this bracket, which is the numerator, over. I'm going to use this down, put a 4 there. That is going to be 1/6. So this is 1/6. And where are we having 1/6? 1/6 is this answer here, which is on D. So meaning to say all these answers that we are having, they are wrong. This is the answer that we are supposed to have at the end. So that was our question 1.3 on this part. All right, they need us to turn over Let's check what we have on the next part. What does, on 1.4, what does 5y minus 1 mean? Okay, they gave us like situations. What does it mean? So let's read. Subtract 1 to 5 and multiply by y. No. Subtract 1 to 5 like this. This is what it means. Then multiply by y. This is the statement. Subtract 1 to 5. It's 5 minus 1. Then you multiply by y. This is not what you have there. No. So this is wrong. B, multiply 5 by y. Multiply 5 and y by negative 1. Multiply 5 and y by negative 1. No, it does not make sense. This is wrong. Add 5 and y and subtract 1. Add 5 and y. This is what it means like this. Add 5 and y. And subtract 1. No, this is not what we have there. This is wrong. Multiply 5 and y, then subtract 1. Multiply 5 and y. 5 and y. Then subtract 1. This is exactly what we have there, because 5 times y is going to give us what? 5y minus 1. So this is true. So the answer was going to be a D. So this type of a question, you just have to understand like how you're given. It's not like you can say this, I'm going to revise something like this. No, this one just have to answer according to the question. Consider the ratio below and determine which statement is not, and they even write this in upper caps so that you see they want the part which is not true, which means they want us the part which is what? Which is false. If it is not true, it means it's what? It's false. 2 packets of chips as to 2 pieces of chicken. Okay, let's see. For every 8 pieces of chicken, there are 2 packets of chips. 8 pieces of chicken, 2 packets of chips. This is exactly what we have there, only that they started from this side. 2 as to 8 is the same thing as 8 as to 2. Okay, it's just one and the same. As long you are you're changing the same thing, all right? You are interchanging everything. The ratio of packets of chips to the pieces of chicken is 2:8. Packets of chips to the piece of chicken is 2:8. This is exactly what we see here. This is correct. The ratio of packets of chips to the pieces of chicken, packets of chips to the piece of, it's 8. No, the packets of chips, there are 2. The packets of chip, this one, the packets of chips, that's the first thing. There are 2, not 8. So this is wrong. This is wrong. So meaning to say this is the one that is not true. This one is not true, it's false. The ratio of the pieces of chicken to the packets of chips is 8:2. The pieces of chicken, it's 8. Then the packets of chips is 2. This is correct. So meaning to say the one that is false or the one that is not true, it was C. Okay, so the answer there was supposed to be a C. That was your 1.5. Okay, on question 2, we are given the following ladder shows. This is the section B of our question paper now. So we are given the ladders that are showing the prime factors 420 and 100. So this is 420 and 100. So we are given the prime factors of these numbers, the prime factors of 420 of 100. Write down the HCF of 420 and 100. What is going to be the highest common factor of these numbers that we are seeing? So you can determine the HCF by looking into these numbers. Like 2 is common here. Like I can see that the highest common factor is supposed to be common throughout. It is supposed to be a common number. 2, these are the prime numbers, these ones. These are the factors, these ones. These are your factors. So you check from those factors. 2 here is common, is the same as these 2. So meaning to say we can take it on the highest common factor as long it's common. Times, you move on. 2 is common, there's these 2, there's also these 2. It is also common. We multiply to another part, all right? So you're going to check, is there anything that is common? We have got a 3 here, but we do not have a 3 this side. So we can't take this 3. There is a 5, there's a 5, there's a 5 here, there's a 5 here. So meaning to say 5 is also common. We move on to this 5 here. We do not have another 5. Already we have taken this, so we can't take this 5 with this one. So this cannot be taken. There's a 7 here. Are we having a 7 this side? No, there's no. So meaning to say it cannot be taken. The highest common factor must be seen throughout. It must be common. So there is a pair of 2. There is a pair of 2. There is a pair of what? A pair of 5. A pair of 2, a pair of 2, a pair of 5. That is how you can determine your highest common factor. From the table, you can determine it like that. So this is going to be 2 times 2, which is 4, times 5, which is a 20. Or you can have your highest common factor by considering the numbers this way. You can consider your numbers. If you do not want to take it from the table, you can write these numbers aside. What is 420? 420 is the product of these prime factors that we are seeing, which is 2 times 2, that is 2 to the exponent of 2, times 3, which is 3 to the exponent of 1, times 5, which is just 5. This is just 7. So this is just a 7, like to the exponent of 1 to the exponent, just like that. There is a 100 that we are given in terms of 2 times 2, which is 2 to the exponent of 2, times, there is a 5, also to the exponent of 2, 5 times 5. So what happens is that the highest common factor, it is the one that is supposed to be common. It's supposed to be common throughout. But you take the one that has got the smallest exponent. It must be common and have the smallest exponent. It must be common and have the smallest exponent. So 2 to the exponent of 2 is common. I mean, 2 is common here. There's a 2. There's a 2 also here. Which one is got the smallest exponent? They're just the same. So meaning to say, I'm just going to take it as 2 to the exponent of 2. Any because they're the same. 3, we have got a 3 here. Are we having a 3 this side? No, we don't have. So we are not going to take this. There is a 5. There's a 5 here. Which one has got the smaller exponent? The one that has got a smaller exponent is what? 5 to the exponent of a 1. That is the one that you take. There is a 7 here, but we do not have a 7 this side, so we can't take this 7. So this is your HCF. 2 squared times 5, that is going to be 4 times 5, which is going to be a 20. 2 squared, that's 2 times 2, which is 4 times 5, that's a 20, like this. So you could have calculated or determined your HCF that way. And write down the LCM. This time, the LCM, you just have to take everything as it is, 2.12. We need the LCM on this part. So on 2.12, so the LCM, this is what you're going to consider on the LCM. You consider every number as it is given. You must take every number that is there. But where these numbers are many, like the 2 to the exponent, like the 2 and the 2, they are the same here. They are appearing 2 times. Here, I'm also seeing it 2 times. So I'm just going to take it as it is. So the LCM is going to be 2 times 2. Then I move on to 3. As long I see a number, as long a number is there, I have to take it. A 3 is there, even though there's no other 3 on this side. On the LCM, you take everything. There is a 5, yes, but where are we having these 5s? Where are they many? You take where are they many here? 5 times 5. Yes, there's a 5, but here they are many. So you're going to take where they are many for the LCM. So that's going to be 5 times a 5. Then a 7 is there. It's appearing. Even though it's only 1, I have to take it LCM. You take everything, every number that you are given there. So most of us, they might have a challenge of multiplying this and that. That's why your calculator is there for the help of your multiplication. 2 times 2, you're going to multiply everything that you are given in this presentation. All right, so my calculator, guys, is just stuck. I don't know. Just look. All right, let's see. That's 2 times 2 times 3 times a 5 times a 5 again times a 7. So that's going to be 2,100. So this is 2,100 as your LCM. So like I said, there are different ways of having this. Different ways. We shall see these as topics as we are doing also topics. Let us be together make sure that you become part of this channel by subscribing so that you won't miss any of the classes that we might have from Meson African motifs. 2.2, choose the correct term in brackets to complete the sentence. A zero is it an irrational number? Is it a rational number, a zero? Remember, zero can be given as 0 over 1. So if it can be written as 0 over 1, it means it's a rational number, because a rational number is one that you can write in form of a fraction, a over b, where b is not equal to 0. And this is not equal to 0. So it means 0 over 1 is a rational number. So this one is a rational number. All right. Complete the table below by filling the missing values. 0.5, it's 50% as a percentage. So this is it. It's a conversion from a decimal fraction to a percentage or vice versa. Guys, this is it. Whether you have a common fraction, whether you have a decimal fraction, to convert to a percentage, you multiply by 100%. So from a fraction, whether it's a decimal fraction, whether it's a common fraction, as long it's from a fraction to a percentage, So on that case, you simply multiply by 100%. That's it. Just multiply by 100%. 0.5 there to be expressed as a percentage this side. It was simply multiplied by 100%. So it's 0.5 times 100%. That's the idea there. Just multiply by 1. And it's just 1 mark. So you can even use your calculator to do that. Even if you are stuck on your decimals multiplication, your calculator is there. So this is just going to be 0.5 times what? 0.5 times 100. 0.5 times 100, which is 100. So if you multiply this by 100, you were going to obtain what? 50, which is this one. So it's the same thing as this number that we are given, 0.73, whatever that you have there, 0.7333, whatever, and so on and so on and so on. Just multiply it by what? By 100%, which means we are going to obtain 73.33, and so on and so on and so on. So this was going to be 73.33%. So this is the conversion to a percentage. Just multiply by 100%. That is the consideration. Or you just move. After multiplying by 100%, you can either move 2 decimal places to the right, or just use a calculator to do that. Just 1 mark for that. Then the conversion from a percentage is a vice versa. You were multiplying by 100% to get this. What do you think we are going to do to obtain this? You divide this time by 100%. So from a percentage to a decimal, from a percentage now to a decimal, you divide. 50%, this one that we see, if we divide it by 100%, we are going to obtain 0.5. 10 into 5, that's 0.5, which is the one that we see here. So meaning to say anything as a percentage, it can be taken back to a decimal fraction. So 105% can be written also as a decimal. So it's 105 divided by what? By 100. And that's going to give us 1.05. So this is 1.05. So just move 2 digits to the left. That's 1.05, or our calculator there. It's there to help us in simplification. So that's it. For 1 mark, I think this is quite enough. At your local store, you get 3 stickers for every 60 Rand spent. If you spend 480 Rand, how many stickers would you receive? Show all calculations. So this is a ratio type of a question, or a proportion, a ratio. You get 3 stickers for each and every 60 Rand that you're going to spend. What if you spend 480 Rand? If you spend 480, How many stickers are you going to have? You do not know the number of stickers that you're going to have. So what you need is to solve for x. You need to solve for x. So it's either there on your calculation, you're going to have 3 over 60 is equal to x over 140 over 48. It's up to you. It's going to be x over 3 is equal to 148. As long you are equating what is corresponding, you are formulating an equation. As long you are formulating an equation from there, what am I trying to say? I can formulate an equation like this, 3 over this. So it's going to be 3 over 60 is equal to, since I took this side 3 over 60, I'm going to take it also this way, the first to the last. It is equal to x over what? Over 480. That's it. So I formulated an equation where I can solve for x. We talked about the cross multiplication when we are solving equations. So I can cross multiply. 480 multiplies this side. 60 multiplies the other side. That is your multiplication. Or simply remove this 480 that we have on this side by multiplying by it. If I multiply by 480 here, I'm simply removing this 480. I multiply by 480 this side, I'm simply removing the 480 this side. So I'll be left with x. So meaning to say x will be equal to this. The product of 480 times 3 over 6. Guys, it's up to you the way that you simplify this. It's up to you. All right, so you are in exam and you are fighting against the time, remember? So your calculator is there again for your assistance. 480 multiplied to 3 over 60. That's 3 over 60. All right, 3 over 60 like this. That was going to give us a 24. So x is equal to 24. X represents what? The number of stickers. So therefore, they are 24 stickers in this case for this amount. So meaning to say the number of stickers that we are going to have at the end was going to be what? 24 stickers that you are going to have in, or if you spend 480 rand. 2.2, by using the answer to question 2.41, would you say the relationship between the amount spent and the number of stickers earned is direct proportion or an indirect? Okay. If we are to check here, there was 3 stickers equivalent to 60 rand. 24 stickers, which are, we have increased the number, also the amount is increasing. So that's a direct proportion. A direct proportion is when both increase at the same time or decrease at the same time. Inverse is the indirect way. So this one is a direct proportion. So that's a direct proportion or a direct variation. That's the idea there. Given this information on 2.5, we are given that 3,030 rand, 5,05 is invested for 5 years. So there is a certain amount of money which was invested, which is the principal amount, for 5 years, which is the time frame that was taken, the time, at 4.5%, which is the interest rate, which is compound interest per annum, compound. Calculate the value of the amount of the investment, which is A, the value of the investment, which is A, the amount that you're going to have after 5 years. Round off the answer to the nearest whole number. To the nearest whole number, that is, you are rounding off to the nearest rand, to the nearest whole number. It's a compound interest, and you're given 2 formulas there. A is equal to P into 1 plus R over this to the exponent of N, or P into this to the exponent of what? Of N. Meaning to say, these are 2 formulas that you can use to calculate your what? To calculate the amount at the end of what? At the end of 5 years. As long you understand what it means on each and every formula that you are given there. All right, let's talk about the first formula. We are given that in terms of R. Amount is equal to what? The amount is equal to P All right, let me just save it this way. Let us take our information first. We are given in this case the amount, the principal, which is the money that was invested. Remember, that's our principal, 3,030,05. In the time frame of 5 years, so that is our N, which is 5 years. So N represents the number of years, whereas the 4.5% is going to depend with the way that you're going to have it here. If you're using the first formula, it means your R is going to be 4.5%. If you are using this formula, this one that has got an I there, I is taken as a decimal percentage. I is a decimal percentage, so I is 4.5% over 100%. So it's 4.5 over what? 4.5 over 100. You write it as a decimal. You remove the percentage. That's what I'm trying to say. So that is going to be 0.045. All right, that's for 4.5 if we take it as I like that. But if you use as R here, you use as it is. So from the first formula, you are going to use your as it is. So A is equal to the principal, which is 3,030,05 into what? 1 plus the rate. So this is the interest rate as it is, which is 4.5 over 100 to the exponent of N, which is the number of years, which is 5. So if you're using this formula, you just take it as it is. All right, so this will be 3,030,05 into what? So if you simplify this on our calculator, or you can even simplify this at once on our calculator if you understand it, or you can just see this part inside of the bracket, 1 plus, let's see what we have. So you see, guys, my calculator is just somehow just misbehaving. So that was going to give us, if we were to simplify this, that was going to be 1 plus 4.5 over 100. All right, 4.5 over 100 like this. So this is the decimal part that we are having. And this was going to give us, let's have it as a decimal. I want to take it as a decimal, 1.045. So this is the decimal part that we are having, 1.045. So this is 1.045 to the exponent of 5. So meaning to say we can have our amount and take note, round off your answers to the nearest whole number. So it means this is going to be 3,030. All right, that's 3,030, 0.05 like this. Into the bracket, you open the bracket of 1.045 like this. Close this bracket to the exponent of a 5. So that's going to be to the exponent of 5, which is you're going to get this value. Then you round off 3,775.99. So the 9 was going to change this into 3,776. Or you can just do this on your calculator. Shift set up. You go to the fix there to one decimal place. You press 1, 2 decimal place. So there we do not need a decimal place. We want 0 decimal place. We do not want anything. That's to the nearest whole number. You press a 0. So it's going to give us 376.00 like that. So you can fix your calculator to the nearest whole number. So it's going to approximate. So this is just an approximation in actual sense. So it's just going to approximate to 3,776 rand. So that is what you're going to have. Okay, so this is what you were supposed to do. With the same calculations, you are going to do that when using the other formula, you are given that the amount can be given as the principal into 1 plus I to the exponent of N. So it's just one and the same thing, only that you are writing that as a decimal. So this, every part is going to remain as it is. Only this part of this I here, which is your interest rate, you just have to write it as a decimal. On this formula, you use it as a decimal fraction. You divide by the 100. So as you can see, it is one and the same thing as what we had. If you add, you're gonna be it's gonna be 1.045. We are back to this stage. You approximate to the nearest whole number. That was it. That was the idea of the question. So they are going to ask questions typically of this nature. You just have to be very, very careful in that scenario. Then question 3.1, they need us to determine what is the additive inverse of 13. Remember, we talked about the multiplicative inverse. This time it follows that the additive inverse is like this. A number, when being added to its additive inverse, which is you multiply it by negative. If it is a positive like this, you multiply it by a negative. That is the additive inverse to give us what? The additive identity, which is a 0. So this is the number, all right? And this is your additive inverse. Your additive inverse. Inverse, all right? And this is your additive identity. Your additive identity. So that is the idea there. So meaning to say that if whenever you're given this, you need to introduce a negative on the number. So what is the additive in, meaning to say this is the number. The number is 13. The number is 13. So the additive is to introduce a negative on that 13 like this. So that it gives us what? A 0. So minus 13 is the one that we want. So the additive of 13 is what? Minus 13. Just introduce a negative. That's the situation of what? Of an additive what? Identity. Study the number pattern below. They are saying is study. To study, you have to understand what is it that they are trying to do here. 2 minus 1, 2 minus 2, that's a 0. 2 minus 1, that's a 1. 2 minus 0, that's a 2. What is happening? 2 is remaining as it is 2, 2, 2. But yes, 2, 1, 0. As you can see, 2 is reducing. 2, 1, 0, minus 1, minus 2, minus 3, minus 4. It's reducing. Then 0, 1, 2. These numbers are increasing. 0, 1, 2, 3, 4, 5. As you can see. What will the next line in the pattern be? What is going to be the next line? Show all calculations. Are there calculations there? Or we are just seeing what is happening? There is a 2 that is simply the same. Minus, we can see that these numbers, they are reducing by 1, 2. Minus 1, that's a 1. 1 minus 1, that's a 0. So it's going to be 0 minus 1, which is what? A minus 1. So meaning to say at this point, there is a minus 1. So it's going to be 2 minus 1. Which is equal to what? 0, 1, 2, we're just adding. So it's going to be a 3. Even if you add here, 2 minus 1. A minus and a minus, that's a plus. 2 plus 1 is what? Is 3, which is exactly what we have. So, guys, nothing there. It's nothing here. There's nothing here. It was just to study your question and see what is happening there. Calculate the following without using a calculator. Show all calculations. Leave the answers in simplest form. So you've got minus, that's 3.31, minus the square root of 6. So the square root of 36, I mean, the number that you multiply to get this 36. That is what? A 6. So the square root of 36 is a 6. Or you can write this as the square root of 6 squared, which is same as a 6 squared over the number inside of the root sign, which is a 2. Remember, square root means what? There's a 2. Okay, it's the square root of 36. You're supposed to know it by head. This is going to be a negative 6 on the square root of 6. We've got minus 6 over minus 1 to the exponent of 3. And if a negative is being raised to an odd number, it remains as a negative value. So this is minus 1 to the exponent of an odd. So it's going to be negative 1 times, this is actually a minus there. That is minus 2 is the one that is being raised to the exponent of 3. So 2 to the exponent of 3 is 8. 2 times 2 times 2, remember? You're multiplying it 3 times. 2 times 2, that's a 4. 4 times 2, that's going to give us 8. So meaning we've got an 8 there. So what are we going to have at the end? Minus 6, everything over what? So these lines, guys, they are just a problem to me if I'm to present these guys. minus 6 over a minus 9, and that's going to be cancel negative, negative. Reduce this by 3. 3 is the highest common factor between 6 and 9. So we can reduce this by 3. 6 divided by 3, that's a 2. 9 divided by 3, that's a 3. So this is going to be 2 over 3. All right, so that is how you were supposed to have determined this at the end. All right, also without using a calculator, so there we are supposed to apply our BODMAS. So if we are to check, we are given 3 plus 6 multiplied to 6 plus a 4 inside a bracket divided to the 5 minus a 7. So according to the BODMAS or BOMDAS, whatever that you're going to have, the brackets, they need to be simplified. So that's it. This is going to be 3 plus 6 multiplied to the, if we simplify the brackets, what is inside of the bracket, 6 plus 4, that's a 10. So everything remains as it is, divided by 5 minus a 7. So if you are using the BODMAS concept, it means you're going to divide. You dealt the brackets, so this time you're going to divide. Which part is dividing? This is the part that is dividing. The part of what? The part of 10 and a 5. So this, everything is going to remain as it is. 3 plus a 6. You divide this part. 10 divided by a 5, that's a 2. So meaning to say this is going to be times a 2 minus a 7. You are done with the division. What follows is the multiplication. Is there a part that is multiplying? Yes, these two numbers, they are multiplying each other, the 6 and the 2. So it means I'm going to have 3 plus, I multiply these numbers. So it's 3 plus 6 times 2, which is 18. I subtract a 7. I move on to the addition. Are there numbers that are adding? Yes, a 3 and an 18. That is the, oh, guys, 6 times 2, that's a 12 there. Sorry, guys, I'm now, where am I now? 6 times 2, that's a 12 there, all right? How did I get this 18? All right, maybe I was writing, not looking here. I don't know what happened. So 6 by 2, that's a 12. Then we're going to add these two. 3 plus, there's an addition. 3 plus 12, that is 15 minus a 7. So 15 minus 7, that is going to be 8. So this is going to give us 8 at the end. So that was it. That was it. BODMAS can be used to simplify these typical questions. Okay, so let's see the other part of the question, which is on question number 4. We were given, arrange the numbers in descending order. Descending order means from the biggest number, 9, 8, 7, 6, 5, 4. That is descending. Ascending order, you are starting with the smaller number, 1, 2, 3, 4, 5. These are ascending order. So in descending order, we need to know what each number represents so that we can see how big that value is. So this one, just use your calculator to verify like the cube root of these numbers. All right, so first thing, I'm just going to need to bring my calculator. Remember, I had to fix my calculator in that question. So now I need this calculator back to the normal mode. So it's shift setup to the normal, that is press 8, press 2. All right, so let's start with the cube root of 64. The cube root, there's the cube root here, is this one. So it's shift here, shift this one. All right, guys, I need shift. You see my calculator is misbehaving. Shift. All right, there's shift cube root of 64. So the cube root of 64 is a 4. So there's a 4 here. This is just 0.8. 0.8 is just 0.8. 1 to the exponent of 3, guys. 1 times 1 is just 1. All right, 1 to the exponent of 3 is just a 1. So there we just have a 1. There's nothing here. 9 over 2, that's as a decimal, it's 4.5. 9 is not going to change. The square root of 25, which is 5, or you can use a calculator, the square root of 25, that's what? That's a 5. So meaning to say, we can properly compare these numbers because we can see them in the way that we understand in terms of what? Whole numbers and decimals. So comparing these numbers in ascending order, which one is the biggest value? Between 4, 1, 0.8, 1, 4.5, 9. 9 is the biggest value, and 9 was taken from where? It was just 9 as it is. Followed by what? 5, 9, 5. But where are we taking 5 from? From the square root of what? from the square root of 25. You write these numbers. These are the numbers that you're given, not these ones. These ones, you just write them so that you compare to see your numbers in order. All right. So 5 followed by what? By 4,5. 4,5, we took it from where? From 9/2. So you write where you took that number from, 9/2. 4,5 followed by what? By 4. We took this 4 from where? The cube root of 64. So that's the cube root of 64. 4. Then we move on to 1. 1 was taken from where? From 1 to the exponent of 3. Then followed by the decimal of 0,8, which was taken from where? From 0,8. 0,8 was just 0,8. So this is the order of the descending order from the bigger value to the smaller one. Writing in the way the numbers were given here, it's you who had to change these numbers to decimal so that you can compare to see which one is bigger between these numbers. But on your answer, you have to write the way that you're given. Use the symbol equal to or the greater than or the less than to make the following statement true between these two numbers. All right, again, you have to compare. Already we talked about this, the cube root of 64. We saw that it was a 4. What about the square root of 64? That's an 8. So is 4 equal to 8? Is 4 greater than 8? Is 4 less than 8? What is it comparing 4 and 8? 4 is less than 8. So if 4 is less than 8, it means also where we took this 4 from the cube root of 64, it is less than the square root of what? Of 64. You have to consider where it was taken from. All right. The following statements are incorrect. Yes, very, very incorrect. These are not correct. 4.31. Write down the correct answers. You've seen that they are incorrect. Yes, now write down the correct answers. So 5 to the exponent of -1 means what? Remember, x to the exponent of -1 is 1 over x simply. X to the exponent of -n, it's 1 over x to the exponent of n. So if you're given a negative exponent, it's just 1 over 5 to the exponent of 1. And 5 to the exponent of 1 is same as what? Is same as a 5. So it's 1 over 5 there, not -5. And most students, they have a tendency of doing this. 4.32, pq to the exponent of 0 is equal to p. No, this is wrong. Pq to the exponent of a 0 like this. If the whole bracket is raised to the exponent of 0, whether it's an addition that is inside of the bracket, whether it's a subtraction inside of the bracket, as long a bracket is raised to the exponent of a 0, it must give us a 1. This is what I'm trying to say. Whether it's an addition, I don't know what is inside of that bracket, as long the whole bracket is raised to the exponent of 0, it gives us a 1, like this. 1 plus 5, 1 plus 6, whatever that you might have inside of this bracket. Maybe it's 1 plus 6, it's 1 plus 5, it's 1 plus... But as long you raise this bracket to the exponent of a 0 like this, it will give you a 1, no matter what is inside of that bracket. So the answer there is supposed to be a 1. Any number to the exponent of 0 is 1. So the whole bracket is also being raised to the exponent of a 0. Simplify the following expression. They were given to simplify this expression. That was our main marks for this expression. It was 4 marks. All right. Okay. What are we having here on 4.4? This is our expression where we are given 16. That's 16a to the exponent of 2. So what the first thing was to introduce a multiplication. The moment you see this, introduce multiplication, then you tip over the second fraction. So this is gonna be, all right, guys, don't mind me because the space there is too small for me to write. So I'm just gonna do the way that I'm understanding, I'm having on my space here. So if I multiply this, I'm gonna invert this. So it will be 9a to the exponent of 4b on top. Everything over, you take this down, that is to tip over, this will be 8a to the exponent of 3b. That is the idea there. So once you have this, you can reduce as long numbers, terms can be reduced. Do that. As long they can be, do that. Like here you can see there's a b and a b. Cancel this. As long as they are the same, 2 over 2 is a 1. So you can cancel the B and the B if it is like that. A condition like that is an advantage to have. All right, anyways, the other part, is there anything you can just maybe reduce the numbers here? 8 into 8, that is 1. Into 16, that is 2. 16 divided by 8, that is 2. 3 into 3, that's 1. 3 divided by 3. 9 divided by 3, that is 3. So we are just left with 2 and 3 in terms of the numbers. Okay. The other thing also is that, you see, guys, it's true that you're supposed to use the laws of exponents. Very, very true. But sometimes you can even cancel, like to say, there are 3 here. There are 3 A's that are here. There are 3 A's. It's like this. A times A times A. On top there are 4 A's. It's like this. A times A times A times A. There are 4 of them. So if you cancel these 3 A's to these 3 A's, how many A's will remain? There's only 1. So some of these ones, you don't need the laws. Yes, you can do that. But you can even consider that there are 3 A's here. So cancel them into these ones, which are 4. I'm going to remain with 1 A. The same thing, there's 1 B here. Here there are 2 of them. So if I cancel, I'm going to remain with a 1 B. But here there's a negative. So never be table, because we can't tell how many A's are there. It's a negative A. We can't say there are 5 A's there. So it's a negative number. So be careful on this one. There is a negative. So let's combine what we have so far. So this will be 2 times 3, which is 6. We are left with the A squared and this A here. So A squared times A, if you combine 2 A's and another A, they are now 3 A's, A to the exponent of 3. Everything is going to be divided. Okay, that is the only A. In the denominator, there is A to the exponent of minus 3, the one I said. We have to just rewrite as it is, and B. Now, these two, we can use our laws of exponents. Since the bases are the same, we know that we're going to subtract the exponents there. The reason, the negative there, if you do not want confusion, just use your laws of exponents. So meaning to say this will be 6, A to the exponent of 3, minus, since we are dividing, we subtract the exponents. So it's minus what? Minus 3. So this is the part of A. But what about B? Is it affected? No, B is not affected. So B remains in the denominator where it is. It is not affected. So this was going to give us 6 minus, that's a plus here. 3 plus 3, that is going to be 6. So it's A to the exponent of 6, everything over a B. So that is what we're going to have at the end. So everything is over a B. That's it. You just have to be careful in your simplification. Very, very careful how the questions are given. How the questions are given. Okay, let's see another part, which is on question number 5. On question number 5, we are given the sequence. The number sequence that we have here, it's 1, 8, 27, 64, and so on. Write down the next term in the sequence. So this type of a sequence, we could have even figured out what is happening here to say, these are perfect cubes, a perfect cube. 1 to the exponent of 1 is a 1. 2 to the exponent of 3 is a, these are perfect cubes. 1, 8, 20, 1, 8, 27, 64. This is 1 to the exponent of 3, 2 to the exponent of 3, 3 to the exponent of 3, 4 to the exponent of 3, 5 to the exponent of 3. So it means 6 to the exponent of a 3 is going to give us what? That's 260. These are perfect cubes. Just like maybe I'm given 125, 116. All right, let's just save them in order. 1, 4, 16, and so on. 1, 4, 9, 16. These are perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, meaning to say the term that is going to be here is going to be a 25. Perfect cubes, perfect squares. You're supposed to know them by heart. Know your perfect squares, know your perfect cubes. Two friends were texting each other. They were just having a text on each other, back and forth. They were using the heart eyes emoji with every text forming the following pattern. Every text that is sent was following this pattern. The first text, there is a single emoji. The emoji that we have is one. But how many hearts do we have? Because we talk about the heart eyes there. The heart eyes, there are two. On the second text, the heart eyes, there are 2, 4, 6. Here there were 2. Here there are now 2, 4, 6, 8, 10. There are 10. So that is what you're having. The number, these are the heart eyes, these ones. We're talking about the heart eyes that we are seeing, which are the hearts. In fact, these eyes are heart eyes, and they are hearts. All right. So these are the heart eyes. They're in form of what? In form of a heart. The heart there. So those are the like number of hearts. So the heart eyes, like we have got what? 2. Guys, this is a single eye, another eye. I hope you understand me, guys. I hope you understand me. But this one, the number of emojis now, if you consider the number of emojis now, let's say these are the emojis in terms of what? I'm going to write them in blue. The number of emojis that we have here, it's 1. How many emojis here? 1, 2, 3. There are 3 emojis here. How many emojis? 1, 2, 3, 4, 5. There are 5 emojis there. So don't confuse between the heart eyes and the emojis. So the question was, complete the table below by writing down the number of heart eyes in each text. By writing, all right, the first text, how many? We say there are 2. This one already counted 2. Here there are 6. Here we said they are 10. All right, so that was it on this question. Using the numerical pattern derived in question 5.21, by the number, all right, by the heart eyes to determine the general term in form of Tn. All right, so we are determining in terms of heart eyes. We could have a pattern in terms of the emojis, just like how many emojis are there. But we are having a pattern in terms of what? The heart eyes. So what is it that we have? If we check between the first and the second terms there is a difference 6 minus 2. There's a difference of 4. Between these also, there is a difference of 4. So meaning say there's a common difference of 4. So it's a linear pattern, this one. Whenever there's a difference, a common difference, it's a linear pattern. So it was going to be like this. It's a linear pattern. So it means Tn is equal to the difference that you are having. So it's going to be 4n plus c. So this one is the difference, the common difference. Tn is 4n plus c. So you need to find this c. So to find the c, you can substitute in any way. So this is it, guys. The text is representing n, the number, and this is your Tn. So if n is 1, your Tn is 2. If n is 2, your T2 is 6. So this is it. So it is like this. T1 is 2. T2 is what? Is 6. When it is 3, T3 is 10. So this is n. This is your n. So you can just take any part that you want, like this one. T1 is what? Is 2. So I have Tn, which is 2, which is equal to 4 into n is the 1. N is 1. N is 1. Tn is 2. So n is 1. You have to find c. So that is 2 is equal to 4 plus c. 4 times 1, that's a 4. So transpose this is going to be 2 minus 4, which is minus 2, is equal to c. So c is a negative 2. So meaning to say, if this c is a negative 2, therefore our Tn was going to be written as 4n. You just rewrite this as it is 4n minus 2. So it was going to be 4n minus 2. So for 2 marks, it's enough. There are so many ways that you can actually use to determine this. We're just going to see them as we are doing these questions. We are together as we are revising. Let's see how it can be like. So if the friends continue using emojis, they're still using this. Using emojis as observed above, how many hearts would be there in the 15th text? So remember, the text is what? Is n. So you are given n there. They are simply saying n is 15. Determine Tn. Determine T15. So you are given Tn. The expression for Tn is this one. So what about T15? So T15 means where there is an n, you are going to substitute a 15 there. Let's subtract the 2. There's nothing that is having that. There's nothing that we have there. So that is the idea there. So you are going to substitute this. That means our T15 at the end was going to be 4 times 15, which is 60. And 60 minus 2, that is going to be 58. So meaning to say there are 58 hearts that we are going to have, which is the heart eyes at the end. They were going to be 58. All right. So that was 5.23. Let's check 5.24. How many texts that we have? The text now were sent if they are 39 emoji first. Take note, guys, there. What are we given here? We are given 39 emoji faces. This TN that you see here, this TN here, is not for image for faces. No, it's for the hearts. We created TN from this one, from the heart eyes, this one. Determine the general term TN. It was from what? From the heart eyes, not the image. The image, like I said, if you see here, there are two different things. The image is like here, it's 1, but the number of hearts is 2. There are 3, it's 6. So the number of images and the hearts is two different things. But we can take that as an advantage to say what is simply happening is that for every part that you have, you simply multiply by 2 to get this. If there are 3, 3 times 2, 5 times 2. So meaning to say, if you are given the number of emojis there, you are supposed to determine the number of hearts first. There are 39 emojis. So how many hearts do we have? Before we talk about what? How many text? How many hearts? How many heart eyes do we have? From 39 images, how many heart eyes? Each image, if you're given each image, it has got a heart. Each image has got what? A heart. So if there are 39, it means 39 times 2, because each image has got 2 hearts. Each image that you see, it has got 2 hearts. So meaning to say, the number of heart eyes that you're going to have for 39 images is going to be 39 times what? Times 2. That was the tricky part of this question. You were supposed to determine the number of heart faces first, which is 78. So if we have got 78, remember the number of hearts is represented. The heart is represented by what? By Tn. Tn is for the number of hearts. So there we are given Tn. It's like this. This 78 that we are seeing is the number of heart eyes. So we are given Tn is equal to 78. So find n, that is the question. How are you going to find n? Remember, our Tn was an expression, how it was given. Tn was given as 4n minus 2. Remember what we had from our previous question, simplification of Tn. We got that Tn is equal to what? 4n minus 2. So with this expression of Tn, now you need to find n. Given the Tn that is 78, you need to find n. Having this, our Tn. So Tn is equal to this. So it means Tn, which is 4n minus 2, is equal to what? The same Tn, this one. The same Tn is also equal to what? As a numerical value, it is equal to 78. So what is going to be the value of n, which is the number of texts? Remember, the texts are represented by n. We talked about it here. N represents the number of what? Of text. So by calculating n, you are finding the number of text. So you are solving. It's now an equation. You have to solve for what? You have to solve for n. So take the negative 2. On the other hand, it's going to be a positive. For n, it's going to be 78 plus 2, which is 80. 72 plus 2, that's an 80. All right, it was a negative. So if add there, If you transpose there, it's going to be a positive. So you divide by 4 both sides. That means our n is going to be equal to what? Our n is going to be equal to 80 divided by 4, which is a 20. So there are 20 texts which were available to have 78 heart eyes, meaning to say we have 39 emoji faces. Understand the question. What are you given? Don't just answer the question. No, understand the question, how it is being given. All right, so that was your question 5.5.24. 5.3, the heights and width of boxes used to store files in a shop in centimeters is as follows. So these are the heights and also the width in centimeters. What is the width of a box of a height of 45 centimeters? Again, this type of a question, it's a proportion type of a question, all right? It's a proportion type of a question where you can say that 60, which is the height, corresponds to 8. 30, I mean, corresponds to 8 as the width. So if 30 is corresponding to 8, what about when, because the question needs us to find the width of the box. If the height is, like, let's say there's a 45 here, what is going to be the width corresponding? So you're simply having the same thing. The 45 being the height, what is the width corresponding? Or you can write in terms of x. It's up to you. You can form an equation. Guys, the formulating of equation, as long as you understand, you can write 30 over this like this. 30 over 8 is equal to 45 over W. You can write it this, as long as you understand this part, as long as you understand how to form this equation. You can also write it this way. This time you can write it as this. 8 over 30. 8 over 30 is equal, as long as you started this way, you're going to also move the same way. So it's going to be equal to W over 45. You can also use it this way. W over, because it's the same, over 8, it must be equal to 45 over what? 45 over 30. We must have the same thing throughout. It must be a tally throughout. It must be a tally, that one, throughout. Must be a tally, anything that you want. So I do not know which way were you going to choose your ratio. It's up to you. Which way? Are you choosing this? Are you choosing this? Are you choosing this? It's up to you. All right, so as for me, guys, I was just gonna choose this one. So how do I calculate W? From here, I can do the cross multiplication, or I can just multiply by 45. To remove this 45 here, I can just multiply by 45 here, multiply by 45 here. So this was gonna cancel, meaning to say our W was going to be equal to this times 45, which was gonna give you a 12 centimeters. Whether, guys, you use cross multiplication, let's deal with cross multiplication this side. You want to choose cross multiplication, maybe let's do it an example of this one. You choose like this multiplies this side, this multiplies this side. So it's W times 30. The denominator to the numerator of the first one. W times 30, which is 30. W, which is equal to 8 times 45. That is your cross multiplication. So that's 30. W there is going to be 8 times 45, which is something like 360. So 360, if you divide this by 30, that means our W was going to be what? If we divide this by 30, we're going to obtain a 12. So W is the width in centimeters. So the width there in centimeters was going to be a 12 centimeters. That's it. So guys, it's up to you. These are different. There is a height and its own, but as long they are corresponding, the way they are given, they are supposed to give us this. You need to know each and every part, understand it. So let's check this one, number 6. 6.1, we were given choose the correct answer in brackets. a variable, or constant is a number that does not have a fixed value. That does not have a fixed value, which is true. A constant is just a fixed value, like just a 2, a 3. But a variable x cannot be 2, cannot be 3, it's just any value. It's not a fixed value. So that's a variable there. So we are supposed to have this as a variable. All right, state if the following statement is true or false. All right, this x squared plus 9 cannot be factorized. So this is wrong. This is false. It is x squared minus 9, which is supposed to give us that part that you're given there from the difference of two squares. The square root of x squared x, the square root of 9, which is 3. So one bracket subtracts another one, add. From a difference, there must be a difference there, not a sum. So this is actually false. All right, 6.3, subtract this from this one. From. That is where you start. You start from. So this is minus 12p plus 12pq. From this, from. We are supposed to subtract. What are we subtracting? We are subtracting this 2p plus pq. So that is the idea there. So what you're simply going to do is to expand the brackets here. There's a 1 there that is outside of the bracket. So if you expand or remove this bracket by 1, here there is a number. Even though we see that negative there, there's a number that is there, which is what? A 1. So it's going to be negative 1. So expand this bracket by 1. So it's 1 times minus 12p is going to be minus 12p. 1 times 12pq, that's 12pq. Minus 1 times a p, that's minus 2p, minus this 2p, this one, 2p, this one. If you multiply, it's going to be minus 2p. Minus 1 and a positive, so it's minus times a positive, which is minus pq. So that's going to be minus pq. So if we were to collect the like terms, the part of p together, you're going to see that these here are the like terms, the 12, minus 12p, and the minus 12, minus 2p that we are seeing there. So if we subtract these minus 12, minus 2, that's minus 14. So it was going to be minus 14p. We move on to the part of pq. This part of pq, this one, there is a 1 there. So meaning say there's a minus 1. So this is 12, which is a plus. So that's we've got 12 minus 1, which is 11. But there is a pq that we are having in this case. So this was going to be a positive, all right? So this is positive 11 pq, all right? So that is what we are supposed to have at the end, considering these terms that we are given. So you have to be very, very careful, your directed numbers, but there your calculator is there as an assistance. So meaning to say, you can use your calculator as an assistance, expand and simplify given these a plus ab plus this squared. All right, we have to expand this. Remember, we can do this. Actually, this simply means there are two brackets there. AB plus B. There is another method that you can actually use the identity. You can just use your identities, but this simply means there is a product of these two, AB squared plus a B again. So if I am to expand this using the FOIL method, it follows that the AB squared here must multiply everything in the second bracket. So it's AB squared times AB squared, like this, AB squared times AB squared. So it's A times A, which is going to give us A squared, then B squared and B squared. So if you multiply these two, you're going to add the exponents. So 2 plus 2, that's a 4. All right. We move on to the other part, again, still on the B, or on the still AB squared. This one, it multiplies this B. So meaning to say this is going to be AB squared times a B like this. So this is to the exponent of 1. So it's going to be 2 plus 1, which is a 3. So that's going to be plus AB to the exponent of a 3. We are done with AB squared. We move on to the other term in the first bracket. The first bracket, there are two terms there. So this time you're considering this term, this one, the plus B. You're focusing on the plus B. So focusing on the plus B, you are going to see that if you were to simplify this was simply the B multiplying this part of A, B squared. So it's like this, there is AB squared, but being multiplied from B. So that's the B and the B squared. That's a 1. So this will be AB 1 plus 2. That's to the exponent of 3. So there we have got plus AB to the exponent of 3. Again, the B, this one, to the last part, which is the B, also to this one, the B. So B times B, that's going to be B squared. All right, sorry for this, guys. This is too close. So that one was going to be a B squared. Simplify this first part. There's nothing common to be added on this one. There's nothing that you can add. But if you check the second part, which is the middle terms, this one, AB cubed and A this, they are the same. And this is simply like there's a 1 here, there is a 1 here. So you simply add 1 plus 1, which is a 2. So that was going to be plus 2 AB cubed. These are like terms. So remember, like terms can be combined. B squared, there's no like term for B squared. There's nothing also written just as B squared. No, there's nothing. So there's nothing also that can be added to this B squared because we do not have anything common to that. All right, 6.5, factorize this. So the first thing there was to rewrite, remember, the format of a quadratic expression, which is a trinomial in this form of ax squared plus bx plus c. This could have been written as 3x squared followed by minus 12x followed by a plus 9. This is what we are used to. Remember the golden rule of your factorization. You have to factor out the highest common factor always when there is a highest common factor, do that. Checking on the numbers, there is a 3, there is a minus 12, there is a 9 there. 3 is the highest common factor. 3 is common throughout this number. So I can factor out 3. That means 3 and 3 can cancel. 3 divided by 3, that's a 1. So you're going to have x squared minus 12 divided to this 3, that will be minus 4x. If you divide 9 divided by 3, that is going to be a 3. So now using the factorization concept that this part is a trinomial that you're used to, a quadratic trinomial, where the coefficient of x squared is a 1. And we understand that if this situation arises, we just have these two brackets where we are going to have an x here and another x, so that the product of this x and this x gives you x squared. So what do you do now? You are going to concentrate on this constant, which is the plus 3. So what you're going to do is to find the products or the factors. These are the products or the factors of what? A plus 3. The products or the factors of a plus 3 should add up or must add up to this minus 4. These two terms that you're considering, the two numbers, if you multiply them, you get a positive 3. But if you add these two numbers, you must have a negative 4. So just from the negative 4 on its own, it means these two terms must be negative. Yes, 3 and 1, they are best numbers to use. But how? It's going to be a minus and a minus, so that the product is a positive 3. But if I add these two, I'm going to get a negative 4. So if I add like this, guys, that's what I'm trying to say. If you add, take your calculator, add these two numbers, you must get a negative 4. This is what I'm trying to say. Minus 3, this one, plus a minus 1. You know that a plus and a minus, it gives you a minus. It gives a minus, which is fine. Or just use as it is, minus 3. So that's a minus 3 there. Plus, remember, you're supposed to add. What are we adding? The other factor that we are given, which is the minus 1. So these are the factors, the minus 3 and the minus 1. If we add them, are we obtaining minus 4? Yes, this is the minus 4 which is the one that I'm talking about here. So these two numbers, they were the same numbers that we multiplied before, and they gave us a 3. If you multiply this, check guys. If you multiply -3 and -1, if you multiply this, you're supposed to obtain what? A positive 3. So they are factors of 3. But if I add them, they are going to give you, us, if you add these two numbers, they are going to give us what? -4. So these are the two numbers that we are going to consider, the -3 and the -1. So that was going to be the completed part, this one. This is our final answer. There's nothing that we're going to do from there. There's nothing common. There's nothing that we can factor out. There is totally nothing. We are done. We are just done. So that is how these questions might be given as 6.6. Simplify the following expression. On 6.61, we are given this expression where we've got a 6p minus 4 plus 2 into the bracket of 2p plus a 3. So how can we simplify this? If we check, there is a bracket that we have, and on this bracket that we are having, there's a number just outside of the bracket, and that number is going to affect that bracket that we're given. So this is the idea there. So with this number that is in contact with the bracket, the number in contact with the bracket is the one that you use to expand your brackets. So meaning to say 6p minus 4 is not affected anyhow. It is not affected. The 2 is the one that you're going to distribute inside of the bracket, 2 times 2, and that is going to give us a positive 4p. Then we move on, the plus 2 and the plus 3, we multiply this, that will be a plus 6. So we can collect the like terms, that means the part with the p together. There's a p here, there's a p here, so it's going to be 6p plus 4p. The constants on their own, so this is -4 plus a 6. Or 6 minus 4. 6 plus 4, that is going to give us a 10. So that's 10p. 6 minus 4, or -4 plus 6, that is going to give us a positive 2. You can also use your calculator to verify on that one. That is a positive 2. So that is how you can simplify. Take note. The part of the bracket here, there is a bracket. What is affecting the bracket? The plus 2, the number that is in contact with the bracket. This one on 6.62, we are given again to simplify already under a multiplication. So what we can just simply do is to factorize wherever possible. B squared plus 5b, there is something that is common there, which is b is the highest common factor. Factoring out b, we are going to remain with what? B squared divided by b, that's a b plus 5b divided by b, that's a plus 5. So it's like this, 5b over b like this, gonna cancel, that's a plus 5. Everything over b squared minus 25. So the b squared minus 25 is a difference of two squares, a perfect square and a perfect square. So remembering that from the difference of two squares, I simply need the square roots of these numbers. The square root of b squared, which is b, the square root of 25, which is 5. One of these is gonna subtract, another bracket is gonna add. That's a difference of two squares. Times, on this bracket, we could see that 3 is the highest common factor between 3 and 5 and 15. So you can factor out 3, and also b is common. So if we factor out 3b as the highest common factor, it's going to be 3b squared divided by what you factored out. The 3 and the 3 was going to cancel. B into the b squared, we remain with only a single b there. That's a single b that we remain with. Minus 15b, the same thing. If we divide by 3b like this, it was going to be 3 into minus 15, which is minus 5. The b and the b was going to cancel. So that's, we have factored out 3b. Then we have got the 6b. There's nothing that we're going to do on 6b. It's just a single term. Can you factor out a single term? No, there's nothing that you can do. So reducing these terms and brackets that we have, as long the relationship that we contain is maintained of the numerator and the denominator. As long it is of the numerator and the denominator concept, the numerator of b plus 5 and the b plus 5 are the same, they can cancel. The numerator to the denominator. the denominator to the numerator. As long as it's like that, we can cancel. Meaning to say I can also cancel the b in the numerator to the b in the denominator. The 3 in the numerator, it's 1. The 3 in this is going to be a 2. 6 divided by 2, that's a 3. So meaning to say I'm done. There's nothing that is left common. In the numerator, we are left with b times 1, which is just a b. All right, so that's b times 1, which is b over. This is just a 1 here. 1 times 2, which is a 2. So it is going to be a b over 2. That's a b over 2. Just like that. So these are the typical questions, very, very typical exam questions that you are going to be given in your final exams. Question number 7, we are given, write the following statement in the form of an algebraic equation. 4 times the sum of twice a number. Which number is it? We do not know about this number, so I'm just going to let x be the number. Let x be the number. All right. So if x is the number there, what does it mean from this part? They are saying 4 times the sum. Let's start with the sum. The sum. All right. 4 times the sum of twice the number. All right. Guys, be careful there. Twice the number, all right? Twice the number means 2 times of that number. So it's like this, twice the number. But they need us to have 4 times the sum of the twice the number and 6, take note, and 6. So it's twice the number and the sum of twice the number and 6. Before we move on to the equal, we just need this part here. This one, the sum, this one. Sum twice the number and 6. So the sum of twice this number and a 6. This is the sum. So they are saying 4 times that. 4 times this sum here. 4 times means what? You're multiplying this by what? By 4. That's 4 times. Equals a 32. It must give us a 32. That is equals 32. So it was an equation that you're supposed to deal with like this part, okay? Which is fine. I mean, to formulate a statement. During the classroom discussion, Mary and Rose disagree on the answer to the equation. This is the equation. D into D minus 2 is equal to D plus 4 into D minus 3. I dealt with these equations as introductions. So make sure that you revise those equations so that you have a full understanding of how to solve equations of these. So they are saying, Rose says the answer is D is equal to minus 12. This is the answer of Rose. While Mary says the answer is D is equal to 4. Determine who is correct. We just have to solve. To know who is correct, just solve. Just solve for D. You just need to solve for D. That's it. By solving for D, then you can be able to tell. You can't tell this one is correct. You have to solve. That is to show your calculations. Or you can just substitute if they are the same on the right-hand side, but know how to solve this. Remember, I talked about this as an introduction of these equations. Expand the first bracket by D. You're going to have what? D times D, that's D squared, minus D times 2. That's going to be minus 2D is equal to, from our FOIL method, you're going to distribute by D throughout here. D times D, that's D squared. D and minus 3, that's going to be minus 3D. We are done with this. We move on to the plus 4. It multiplies everything. 4 times D, that's going to be positive 4D. 4 and minus 3, that's going to be minus 12. So it means that D squared minus 2D is equal to what? To D squared. We can collect the like terms. On the right-hand side, there is a part of a D here and also a D that we are seeing on this part. So these are like terms. So minus 3 plus a 4. Minus 3 plus a 4, that's 1. So it was supposed to be 1D. but 1D is same as what? It is same as a D. Minus what? Minus 12. From this equation, you're going to see that whether I take this D squared this side, or I take this D squared this side, these two are the same. They are going to cancel. If you take it this side, it is going to be D squared minus D squared. And D squared minus D squared, that's a 0. If you take it this side, it's going to be D squared minus D squared, that's a 0. So it simply means D squared and D squared was going to be eliminated. They're the same. So we can transpose the positive D to this side of the equation so that it will be a minus. So there we already have minus 2D. If we transpose the D this side, it becomes a minus D, which is equal to what? To minus 12 already on the right-hand side. Minus 2D minus D, this is a negative 1 there. So it's negative 1, negative 2, negative 1, negative 2, negative 1. That's minus 2, minus 1, which is going to give you a minus 3. So that's minus 3D is equal to minus 12. Dividing by minus 3, since we are multiplying, we're going to divide by this negative 3 both sides, and you obtain a positive 4. D is equal to 4. So if this D is equal to 4, it means who is correct? It's Mary. Mary says the answer is what? Is D is equal to 4. So therefore, Mary is correct. Mary is correct. And that means Rose's answer is wrong. Okay? So that's how you're supposed to have this. 7.3, solve for the unknown in the equation below. What is the unknown? The unknown is x. So they are simply asking you to solve for x. X minus 2 in this bracket, everything over 3 must be equal to 2. Solve for x. This is a similar equation as we are used to these equations where I talked about removing or clearing of the fractions. Every number can be written as over 1 to be a fraction. So that means I can find the LCD of these given denominators, 1, 3, and 1, which is 3. So the LCD, we multiply it throughout each and every part of the equation by the LCD. 1 into 3, that's 3 times x, which is 3x. So that's 3x there. 3 and 3, they cancel. We've got a negative 1. So it's going to be a 1, sorry. So 1 times this negative. So it's going to be negative 1 into the bracket of x minus 2. This is equal to this part. If you multiply, that was going to give you a 6. We were clearing the fractions, but now we have got a bracket to be considered. So you have to expand the bracket by what is outside of the bracket, the term, the number, whatever that is outside, multiplying in contact with the bracket, which is the negative 1 in this case. So distributing out by negative 1, that's going to be negative 1 times x, which is negative x. Negative 1 times this negative 2, that's a positive 2. Negative times negative, that's a positive, and this is equal to 6. So 3x minus x means we are subtracting. There is a negative 1 there, so it's 3 minus 1. 3 minus 1, which is 2x. But there is a plus 2, which we still have, equal to 6. Transpose this or take this to the other side of the equation. The moment that it jumps the equal sign, it carries a negative. It was a positive, so it is going to change its sign. It's going to carry a negative. So that's 2x is equal to 6 minus 2, which is a 4. 2x is equal to 4. So you divide by 2 to have the value of x. So the value of x was going to be what? This is 4 divided by 2, which is a 2. So that's x at the end was going to be a 2. So you have to be careful in your solving of the equations, whatever that you are given, very, very careful how you solve your equations. 7.4, we are given, you decide to buy 2 types of chocolates. Since they are 2, it means they are different types. 2 types, they're different types. So we can let x be the first type, and y be another type. So we've got two types of chocolates. So we're gonna have X and Y. So we need to sell, all right, you need to sell this at your school's Entrepreneurs Day. The one type of chocolate costs, all right, the one type of chocolate costs 8 Rand and the other one costs, all right. You spent 150 in total on 22 chocolates. How many of each type of chocolate did you buy? So these are simultaneous equations, like word problems, which generates simultaneous equations. So let's do this. We have got an equation in terms of the amount you spent 150. Let's talk about an equation about the amount of money which was spent. You have 150. Let's say this is the first type, which costs 8 Rand. And the second type is the one that costs 6 Rand. How many are we, or the amount that you're going to spend is what? It's 850. It's 150. But we are saying each one, it is costing 8. How many are we having? We do not know, but we know they are represented by what? By X. They are represented by X. It's like this. If one costs 8 Rand and you buy 3, how much are you going to spend? You're going to multiply 3 times 8. If you buy 4, it's going to be 4 times 8. If you buy 5, 5. So if you buy X, it's going to be what? X times 8, which is 8X. The same thing here. If you buy Y, which costs 6 Rand each, it's going to be 8Y. It's going to be 6Y. I mean, that's a 6 there. So it's going to be plus 6Y. So this is the equation for the amount of money which we have. You bought these ones at what? At 150 Rand. So this was from the amount. It was from the amount. There is another inequality. There's another equation to be formulated from the total of the chocolates that we have. The total chocolates that you have. The type X and the type Y that you have together combined, type X and this type Y that we do not know. How many chocolates were we having? We were having 22 chocolates. So there are two equations which can be formed from this just information that you see. That information that you see there, two equations were supposed to be formulated. So since we are worried about the type of each chocolate, the type that we have is X and the other one is Y. So we are simply supposed to solve for X and Y. For solving X and Y, thus we are finding the type of the chocolates. So I don't know which method are you going to use, elimination method, substitution method, whatever method, there is your choice. So as for me, I'm just going to use substitution method here. So this is what I'm having, equation. I'm going to have this as my equation 1 and this as my equation 2. So it's easier for me to work with equation 2 and to make whatever that I want to be the subject from equation 2. Is it X or is it Y? It was easier for me to do that. So from equation 2, so I'm going to do this. From equation 2, I'm given this as X plus Y, which is equal to 22. So I can make X the subject. I can make Y the subject. It's up to me. So I want to make X the subject. So X is, I transpose the Y to the other side there. So I have to transpose this. So X will be equal to 22. If I take Y to this side, it jumps the equal sign. It's a minus. So X is equal to 22 minus Y is another equation, which we can refer as equation 3. So equation 3 was made the subject from equation 2. Remember, we're working from equation 2. So you substitute in the other equation, meaning to say you're going to substitute in equation 1, not equation 2. You substitute in the other equation. So you are going, since we are using substitution method, so this is it. We are going to substitute equation what? That's our equation 3 into equation 1. So in place of X, you are going to substitute this X that you have, which is 22 minus Y. In place of X of the equation 1, this one. So it's going to be 8X. Our X is what? our x is given as 22 minus y like this. All right, we have substituted x, but this part, there's nothing that is affected, so it's going to remain as it is, plus the 6 of y is equal to 150. So that's it. From the substitution, the part that you have made the subject, you now substitute it. After that, expand the brackets, then solve 8 times 22, that's 176. 8 times minus y, which is minus 8y, plus 6y is equal to 150. So collecting the like terms, we can simplify this. 176 minus 8y plus 6y, that's minus 8 plus a 6. And that was going to give us minus 2y, which is equal to 150. We want to solve for y in this case, so we can transpose this to the other side. It becomes a negative there. So that's minus 2y is equal to 150 minus 176, something like that. If you subtract properly on your calculator, you're going to get negative 26. Divide by negative 2, both sides, y was going to be 13. Negative 26 divided by negative 2, that's going to be a positive 18. So if y is equal to 13, what about x? Because we need x. So already we have x as the subject on equation 3 here. Yes, you can substitute in any equation, either equation 1, equation 2. It's up to you. But you can take advantage of equation 3 because already in equation 3, x is the subject. X is equal to 22 minus y. So x is equal to 22 minus the value of y that we have here, which is what? Which is 13. So x was going to be 22 minus 13, which is 9. So you could have taken advantage of that. So if x is 9 and y is 13, it means how many chocolates that cost 8 rand? Remember, x is those ones that cost 8 rand. So therefore, they are going to be 9 chocolates. There are 9 chocolates for this amount. That you are given for 8 rand. Then for 6 rand, chocolates, remember there's another part, 6 represents y there. And they are 6 chocolates, and there are 6 chocolates to be considered there for what? For this amount of 6 rand. All right, for 6 rand. There is a certain number that you have from the calculations in terms of x and y. But what does it represent in terms of the given information that you have there? You answer it that way. But what is important there is that you have solved your simultaneous equations properly. You have solved your equations. You've formed your equations, after forming the equations, you solve them properly. That is what is important. So this was a June examination from the province of Gauteng. June 2023 examinations having a total of 75. So we shall have more questions of these so that you'll be able to check how to simplify and work out these typical exam questions. Prepare yourselves for the exams that are ahead of time.